You are welcome back to another interesting question. Today, we are looking at a beautiful geometry puzzle involving a cyclic quadrilateral, a quadrilateral whose vertices lie on a cycle. And in the diagram, we are given two congruent angles at point P, each labeled A. We also know the length of line PS is 12 meters, and importantly, line QR is the diameter of the cycle. With this piece of information, the question is, how can we find the area of this cyclic quadrilateral PQRS? It looks simple, but it hides a very elegant geometric relationship, and once we unlock it, the entire area falls right into our hands. Starting from the king, line QR, the diameter of the cycle, it subtends this angle QSR and this angle QPR to the circumference of the cycle. From the cycle theory, it is known that the angle a diameter subtends to the circumference of its cycle is right. So therefore, the two angles are right. But this here is divided into two halves. So since the complete angle is 90 degrees, each half is going to be 1/2 times 90 degrees, which is 45 degrees. Now here we see this angle and this are subtended by this arc RS to the circumference of the cycle. Once again, from the cycle theory, there is a rule that the angles subtended by an arc to any point on the circumference of the cycle are equal. So since this is 45 degrees, this must also be 45 degrees in size. Where do we go from here? Let's take a look at this triangle. It is a right angle triangle and it has an angle 45 degrees. The only right angle triangle with an angle 45 degrees is an isosceles right angle triangle. And in an isosceles right angle triangle, the perpendicular sides are congruent. That is, this side and this are equal. We label them X each. Since the triangle is right, we can use the Pythagorean theorem on it. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. Let it be D. So by Pythagoras, it is D squared equal to X squared plus X squared. X squared plus X squared is 2X squared. Take the square root of both sides of the equation. Here, square root of D squared is D, while here, square root of 2X squared is X root 2. So D equal to X root 2. Put it here. Now let's come back to the cyclic quadrilateral. There is a beautiful idea discovered by a mathematician named Ptolemy. His theory states that for any cyclic quadrilateral, the sum of the product of the length of its opposite sides equals to the product of the length of its diagonals. That is, the summation of the product of this say 2h and this x, and the product of this, say 2v and this x, must be equal to the product of this line PS, which is 12 meters in length, and this line QR, which is x root 2. So 2h times x plus 2v times x equal to 12 x root 2. Here 2 and x are common. We factor them out. So 2 times x into bracket h plus v equal to 12 times x root 2. X on the left eliminates x on the right. 12 divided by 2 is 6. And 6 times root 2 is 6 root 2. So h plus v equal to 6 root 2. Come here from vertex R. Construct a perpendicular to this side PS. Then take a look at this triangle. It is a right angle triangle and it has an angle 45 degrees. That makes it an isosceles right angle triangle. So this side and this are congruent. If we let this be Z, this must also be Z. Now since the triangle is right, we can use the Pythagorean theorem on it. This is the hypotenuse. So the equation is going to be 2v all squared equal to z squared plus z squared. 2v all squared is 4v squared. Z squared plus z squared is 2z squared. 4 divided by 2 is 2. Take the square root of both sides of the equation. Here square root of z squared is z, while here square root of 2v is v root 2. So z equal to v root 2. Substitute it here. Come here to, from vertex Q, construct a perpendicular to line PS. Look at this triangle. It is a right angle triangle and it has an angle 45 degrees. That makes it an isosceles right angle triangle. So this side and this are equal. If we let this be T, this must also be T. This is the hypotenuse of the triangle. So using the Pythagorean theorem, 2h all squared equal to t squared plus t squared. T squared plus t squared is 2t squared. 2h all squared is 4h squared. 4 divided by 2 is 2. Take the square root of both sides of the equation. Here square root of t squared is t, while here square root of 2h squared is h root 2. So t equal to h root 2. Put it here. Come to this triangle PRS. To calculate its area, the formula is 1/2 base times height. If we take this as the base, this must be the height. So base equal to line PS, which equal to 12 meters, and height equal to v root 2. So area of triangle PRS equal to 1/2 times 12 times v root 2. 1/2 times 12 is 6. 6 times v root 2 is 6v root 2. Come to this triangle also. To calculate its area, if we take this as the base, this must be the height. So the area is 1/2 times 12 times h root 2, which is 6h root 2. Now it is clear that the area of these two triangles, triangle PRS and triangle PQS, adds up to give us the area of the cyclic quadrilateral. So area of cyclic quadrilateral equal to 6v root 2 plus 6h root 2. Here 6 root 2 is common. We factor it out. So it is 6 root 2 into bracket v plus h. V plus h is h plus v. And here we found h plus v equal to 6 root 2. Insert it here. 6 root 2 times 6 root 2 is 6 times 6 times root 2 times root 2. 6 times 6 is 36. Root 2 times root 2 is 2. 36 times 2 is 72. So area of cyclic quadrilateral equal to 72 meters squared. Thank you for watching. Please like, share and subscribe, and also turn on notifications. Thank you.